Welcome to the IATA webinar on OneRecord Insights. So this session today is the third episode in a series of 6. Hopefully you've joined the first 2 as well. If not, you can still look at them because the recordings are available. The topic today is crafting ontologies from physical freights to machine-readable data. We have 2 speakers today. First, we have Rene Pietzsch, who is the Head of Product Management, Linked and Semantic Data Consultant for eccenca, and Andra Blaj, who is the developer of OneRecord, and they'll both be presenting different parts of this presentation today. My name is Henk Mulder. I'm the Head of Digital Cargo, and I'm very happy to have this series of webinars. As you can see, we already had a couple before. The first one is a secret. It's actually an overview of all of the episodes that we have had. The second one was last week, which was on the data model, which is a digital twin of the air cargo industry. Today, as I said, is about ontologies, so we'll be hearing more about that in a minute. And we have 3 more to come after this, every week. Tuesday, same time, 11 o'clock to 12:30 CST. Next one is on APIs, the OneRecord APIs. We'll then have one about security, data security, and the last one about the pilots. So today we're going to dive into the world of ontologies. Very, very interesting topic, as you're going to find out in a minute. If you haven't heard of this before, you're going to find a new world of where this data sharing world, the world of data sharing, the world of the web, the semantic web, linked data, all of this stuff. By the time this session is finished, you'll know a lot more about it, and you'll see why we're focusing on this for air freight and logistics, because this really is where the future is. So this is a super important topic today. The presentation today is going to be in 5 parts. We'll first look at the history and context. We'll then look at how would you actually make a ontology, how would you craft it, how would you operationalize it. It's an important topic because we've done a lot of design so far with OneRecord. How do you actually make it work? We'll then dive into OneRecord itself and look at how the OneRecord ontology works, and then we'll have some time for questions and answers. In terms of this meeting, this is a webinar, so you can only hear us speak, the presenters. Your microphones are automatically disabled. However, you can use, and you should use, the question box, which you'll find there's a tab there somewhere, or a little icon somewhere, where you can actually ask questions, and at the end of the session, we'll have time to respond to those. So please, during the session, feel free to ask questions. We've also recorded, we'll be recording this meeting. What you'll actually find out is if you or your colleagues, for example, didn't have time to attend this one, the invitation that you were sent, that's actually in your linked in your calendar. If you click on it afterwards, is the recording. And with that, I propose to move on to the first speaker, which is Rene Pietzsch, who will be talking about the history and context of OneRecord and linked data and ontology. So, Rene, over to you.
Yeah, hello, good morning, good afternoon, wherever you are in the world. And yeah, thanks, Henk, for the introduction and for the chance to be here today and the opportunity to talk to you about this interesting topic. Yes, Henk said, I'm heading product management and working as a linked data expert with eccenca. Eccenca is a German-based software vendor. We are doing software to help our clients to build their own enterprise knowledge graphs, but we get to that in a second. But happy to talk today about building and crafting and operationalizing ontologies. But before we dive into these, a bit of a background on ontologies. So when we talk about developing semantic data and ontologies, we are actually talking about invention of great people and bright minds like him, Tim Berners-Lee. So and very much like the web that he invented and you're using every day, the web of documents in your browser, he started a couple of years afterwards to develop a web of data, where he envisions the future of how we all should collaborate on data and work together on schemas. And so him and other developers basically laid the foundations of the semantic web, which is also called the semantic web layer cake, which is pictured here. And which is basically a framework of W3C and thus open standards. And I think Henk already emphasized the importance of open standards in order to foster collaboration very much in the first 2 episodes of that webinar. So it's extremely important that all these standards are freely available, so everyone can contribute, can take them to the next level, and they are here since decades now. So they are matured standards that can be used to build your semantic solutions. And today we specifically focus on these 3 things, and we'll decompose them in a second. But when it's about ontology designing and ontology modeling, you specifically will need to deal with RDF, RDFS, and OWL. So let's take a quick look into RDF, RDFS, and OWL. For those that are not already familiar with these aspects, I'll quickly explain what they are based on this little graph that you see here in the picture. So when you take a look at the graph, you'll easily notice that the graph consists of nodes and edges, right? So you have these rectangles, and they are connected via edges. They have a direction, they have a little arrowhead, and they also have a label. And with looking at these nodes and edges, we are already at one of the first elements of those 3. We are basically already talking about RDF, which is the resource description framework. And simply put, RDF defines the lowest level of the graph data structure, the triple, right? So every statement that you can make, every fact, we also call them statements, actually can be expressed in a triple, basically, in something that consists of a subject, a predicate, and an object. And much like basic English sentences are built out of these components, we now have a language that's equally well understandable by humans and by machines as well, right? So we created a machine-readable structure, but one that is self-sufficient and self-documenting enough that also human users can actually make reasonable use of that. All right, so back to our original picture. Now that you know that we have these triples, we can actually start finding some, right? So we now have here the subject, Jimmy Page, the predicate is A, and the object, person. And I guess you'll find more of those triples in that picture, right? So Led Zeppelin records, Led Zeppelin 4, and probably another one. Led Zeppelin has a track Led Zeppelin 4 has a track, Black Dog, and probably a final one. I guess you get it, right? So this graph actually contains these triple elements, and that's what RDF is about, this very basic grammar and structure. But RDF, the resource description framework, as the very basic foundational layer, already describes more. It also describes and defines first properties, like in this case, the type statement, where you can actually constitute that a specific resource, like in this case, Led Zeppelin, is of type is a band, or Jimmy Page is a person. So this specific property that you use to assign a type to something, this is defined in RDF. And there's more in RDF, right? So RDF, there's more to add to that actually, which is coming from RDF schema. So RDF schema as a schema language adds more concepts that you actually want to make use of when you define your data models and your ontologies or schemas, which is the concept of a class. All the yellow boxes on that page are actually classes, right? RDFS also defines concepts like subclass of relationships. Creative work, for instance, is the common base class of the subclass album and song. So album and song are both creative works, but special types. And RDFS also allows you to introduce and declare your own domain-specific properties, right? So in this case, that's obviously an ontology about music. So it describes the has track, release date, records, and has member properties, excuse me. OWL actually adds to that. So it takes basically the schema language to the next level, if you will. So OWL stands for the web ontology language. And OWL actually allows for a more fine-grained modeling and also for the expression of constraints, which is very important. So just to quickly walk you through what OWL defines. So OWL also defines a concept of class. So those classes are basically could also be modeled as OWL classes instead of RDFS classes. But OWL actually adds more to that because it allows you to distinguish between different types of properties. Like for instance, we see this violet oval here, which circles a so-called data type property. A data type property is an edge that connects a node with a literal value, with an actual data point. In this case, it's a date, but it could be a string, it could be a number, So the actual data that you need to represent is connected through data type properties. And they can be distinguished from those blue ovals, which connect a node with another node, and they called object properties. They connect two objects. And what OWL also adds is pictured here. So you can, for instance, have cardinality constraints, but it actually introduces the very generic concept of property restrictions. So you can, for a specific property, define how many times it should occur, in which kind of contexts it should occur, and so on and so forth. And this property restriction will be very useful and helpful when it actually gets to validate your input data against a specific schema. All right, that much of a forward about RDF, RDFS, and OWL. When we talk about data on the web, and I think One Record is actually much about that, sharing data with others. I always like this kind of scheme, and this also is a picture and the schema introduced by Tim Berners-Lee, the 5-star scheme of linked open data principles. And here he basically declares what you can use to judge how open and accessible your data actually is. And that schema is very easy to explain. So you should actually start to put your data on the web, actually, ideally with an open license, but this is actually something when you want to emphasize the open thing of that whole endeavor. So put the data on the web somehow, make it machine readable, use non-proprietary formats. And up to that 3rd star, you can actually achieve everything without tapping into RDF. So you could use a CSV file, for instance, share your data in CSV, XML, or JSON, or whatsoever. You would be fine with that. The 4th star, actually, it can be reached once you adopted RDF. And the 5th star is actually given to you when you start linking RDF. Okay, now you might ask what linking RDF actually means. And let's quickly take another picture. I like that also very much. This is done by a research group around Richard Ziganiak, and these people, they monitor the development of the linked data web since 2007. So each of those circles on that canvas actually represents a data set, a database, if you will. They have very elaborate criteria when they would accept new data sets on that map. So for instance, you need to have more than 1,000 triples. We just learned what triples are. You need to have more than 1,000 triples in your data set. And you also actually need to have 50 or more links that connects resources in your data set to resources in another data set, right? That other data set sits somewhere else on the world, authored and published by someone else, not necessarily by yourself. But you actually start linking. You start linking resources like the band Led Zeppelin to albums that someone else probably monitors, right? So that could actually be a link, right? So you link information about the band. So you are basically a Led Zeppelin fan page, and you actually want to link details about the records to someone else's database that more focuses on the recordings and details about that stuff. All right, and these people basically monitor the evolvement of that kind of linked data web over the last 13 years, so to speak. So this is where we reached in 2009. This is where we have been at 2014. And right now we have more than 1,500 data sets that are in their catalog. That they, at some point in time, they started to classify in which domains these data sets are. So it's a very interesting resource. You'll find a link on the slides. So, all right, so that much of a forward. What kind of basic building blocks in terms of techniques you need in order to create an ontology, and also why it's actually worthwhile to create an ontology, and that it's also worthwhile to start sharing data adhering to ontologies like those people in the open data sphere has done. So yeah, let's actually look at how to craft and start ontology building. So let's very briefly introduce what ontologies actually are. So many of you actually already know it. Some of you have probably already played around with the One Records ontology. So ontologies are a shared structured conceptualization in a specific domain. So what that does mean, so let's decompose those 3 elements. So conceptualization is you have a simplified view, an abstract simplified view of things that represent your domain. These things are most often objects and the relations between them. It need to be structured according to a specific modeling scheme. We just have been introduced to RDFS as the schema language, and OWL as a more advanced version of it. So probably you would want to adopt OWL or RDFS. There is also SCOS in the RDF sphere available, which allows you to create a term hierarchy. And this ontology should ideally be shared. right? So that other experts in the same domain have a chance to review your work, to base their own work on top of it. So ideally, you will want to have others to collaborate with you together on this ontology. Domains can vary a lot, right? Could be very basic generic things like persons, places, activities. For all those things, ontologies already exist. But it also could be very special areas, like in our case, air cargo, like supply chains. That's something eccenca worked on before. I'll talk about it in a second. So it could be extremely specific. So let's get into it. But yeah, wait. So before you actually start your own work on a new ontology, you should actually ask Google, right? So you should search for prior work. You should search for others that probably already took the endeavor to model something in your specific domain. I took that little screenshot here from LOV. It's also linked on that slide. It's linked open vocabularies. It's basically a Google for ontologies. So before you actually start into your own ontology work, look around, familiarize yourself with the concepts that you see here. So all those bubbles here on that canvas actually represent vocabularies. So friend of a friend is an important one. DC terms is probably something you came across that allows you to model and represent metadata of elements. Schema.org is also a very famous one. So yeah, familiarize yourself with the existing ontologies. Probably there is material that you actually can use directly and right away, or probably there is material that you at least want to use as an inspiration or as something to fork from and to base your work on top of. All right, so when you identified that you really need to start your own ontology engineering endeavor, then obviously you think, what's the right methodology? And simply put, there is no single right one way to go, right? The experience that we made, that's what's stated here below in that slide, whatever you do in terms of ontology creation, it's necessarily an iterative process. So the results must be discussed, they must be applied, and they must be refined, right? So you will never get it right in the first attempt, regardless how seasoned your ontologists are and how well they know your domain. It would be a very rare condition that you have a seasoned ontologist that is a very specialist in a specific domain so that he or she can get it right in the first place. Also, I like what Henk said in the first two webinars, where they said, okay, now they reached a point where they have sufficient material to be shared with others, but they are also in a phase where this now need to be used, it need to be applied, and it need to be taken to the next level. So obviously they are at a milestone here where they start into the next iteration of their endeavors here. So, and I can only echo that. All right, in general, you would start identifying concepts that you would want to put in your domain. These concepts should be very close to objects in your domain, either physical, logical, and you also would like to look for relationships that connect these objects in your domain to each other. Right, so we look at material and how to actually distill a starting point for an ontology from that material in a second. But most likely you would look for nouns. They could be indications for objects. You would like to look for verbs in your materials. They could be indications for relations between those objects. So actually you should have sound material that describe your domain as a good starting point. All right, and yeah, next question, obviously, when you start to develop, when you start to familiarize yourself with domain material, so what is the right scope and how do I find the right requirements that I need to embrace and encompass in my ontology work? Again, there is no single true answer to that. It very much depends. Here's just a handful of questions that should act as a guiding principle. So obviously, the question is, are you on a green field, right? Can you do whatever you want? What's the target group of the ontology? Do you aiming for a very easy to understand and comprehend data model, or do you need to actually deal and adhere to legacy structures and to some compatibility with those? Do you need metadata, and to what extent, right? What other data sources are relevant? Where do you actually feed information for the ontology? And obviously, as already discussed, are there potential prior works in terms of this domain? And yeah, to what extent you want to reuse them. So these are just very practical but yet general things that you need to consider before you start, and yeah, when to actually make the next check mark in terms of ontology milestones. A very useful technique, as we discovered, and that's also something that we use in our work, are so-called competency questions. So it's yet easy, but at the same time extremely powerful. So you would start creating a catalog of questions that you would expect your ontology to be able to answer for you in your domain, right? So in the product domain, for instance, you would like to ask in your data set what kind of products are similar, and what does the similarity means, right? So do they have similar dimensions? Do they have similar weight? Are they similar according to a specific interface or to a specific standard compliance or whatsoever? And that are actually some sort of question that describe what specific capabilities need to be encompassed and need to be built in your ontology. And after each development milestone, actually, you iterate with example data, you iterate over this question catalog and see to what extent you are already able to answer those questions. All right, source material, I make it quick on that one, as the picture already implies, could be almost anything, right? You could start with Excel documents, you could start with database dumps, you could start with PowerPoint slide decks, product catalogs, so whatever you can get grips of, take it, right? A very sourceful resource are obviously experts. So if you can get hold of seasoned domain experts, try to convince them to help you and start into discussions and into iterations and workshops with them. That's extremely helpful to get it right in very short iterations, actually. All right, okay, so let's start in a very practical example and walk you through bootstrapping an ontology for a specific domain. So let's, for example, take those few sentences about sample domain, in this case, a product domain. So we have some manufacturer that's producing products. And let's see how we can use this as a source to start into a conceptualization of this particular domain, right? So in this case, we have the sentences, our company's physical products and services are managed by product managers. The practice of product management in this company is distributed across all departments in which they have a direct report. Products are structured into categories for which expertise exists in the product managers and in the responsible departments. And for example, our P5 516 named Film Multiplexer Retrostat is managed by Kirsten Bauer in the procurement department. All right, so let's get started. And let's, as I said, as a first step, we want to extract concepts, right? So in order to find concepts, we would focus on key nouns in these materials and highlight those that could make interesting candidates for being created as concepts to describe this domain, right? So in this example, we find candidates in product, in the service, in the product manager, in the department, in the direct report, in the category. All right, so these are example concepts that we could extract from the text. As a next step, we would then look at verbs, not necessarily verbs, but most often these are verbs or other indications of relations between those concept candidates. So we actually want to look for relationship candidates. So in this case, we see that a product or service is managed by a product manager. So this manages is something that relates those two. We see that product managers in a specific department have a direct report. So there is a relation between the product manager and a direct report, whatever that means. So product services are structured into categories, a relation between product and categories, obviously. Then we have a relation between categories and product managers in an area of expertise, right? So they have expertise in a specific category. And also in a specific department in terms of a responsibility, right? So we have now found a handful of relationship candidates. As a next step, not always, but most often, we also do see some sample data in the material that we find. So if you take a product brochure, for instance, there's tons of sample data, right? So all the products that the company will offer could actually act as potential instances. And yeah, why they are so important? Because they can be used to kind of verify the stage of your ontology, right? So the concepts that you created, the relationships that you created, are they sufficient to represent all the relevant contents that you see in terms of instance data that you found? So in this case, we have a specific product number that we see in the sample material. We have a specific name, a specific product, a specific department, and also a specific product manager. So 4 instances that we see here in this material. And finally, we also check if we see some candidates for attributes. So in this case, we at least found one, which is a name, so a specific name of a product. So that's obviously a data type property, as I called it earlier, a data type property that would make a candidate for potential attributes. All right, so that much of preparation for this domain. Now let's actually start creating and formalizing the ontology. So there are, again, different methodologies. So you could go top down, right? So start with the most generic classes and then start to subclass from that and to specialize. There's also the inverse way, right? You start bottom up. You have very specific classes, the very most specific thing that you can think of in your domain in front of you. And then you start to kind of build broader relations on top of that. You start to generalize. And I think that's also a very reasonable starting point, what's called middle out, right? So you start with useful salient classes first. That's most often also the material that you find, because in many times there is more special things to be considered. So there are things that you would like to subclass into, but you don't know them yet because you're not yet a domain expert when you start doing the modeling work. And there are also most often more generic concepts on top. But yeah, it's a good way to start with the salient classes first and then specialize or generalize as you see it appropriate. All right, and then again, we just remind ourselves of the class candidates that we found. And next is take a pen, take a sheet of paper, go to your whiteboard and actually start to structure them, right? And that's actually what I also like to do with you. So just, first of all, let's just put them on the wall, put them on the paper. And then, let's think of some relations in terms of structure, broader and narrower relations that probably do exist between those elements. And most likely you will realize that, okay, if we have hardware products and service products, there is most likely a generic base product on top of that. So you would want to have the subclasses hardware and service pointing to a product as the more generic class on top. And likewise with employees and managers. So you could consider employee as being a special type of an agent. There might be also autonomous agents that could be relevant at some point in time in your model, probably not with the material that we just had in front of us. But you also know that there is a special employee with a special role and a special task, which is the manager, right? And there are those others, department and category, that do not yet have a connection in terms of a classification hierarchy. But they'll probably get into the picture in the next iteration, which means that we'll now also deal with the relationship candidates and put some context in those classes that we defined here. So we see employee is an expert for category, product is a category, employee manages product, manager is a direct report for an employee, and so on. All right, then finally we'll also add the attributes. They are here basically added to this boxes, right? So an agent has a name, a department might have a name, a product can have a name and an ID, as we know from the sample material, and the category probably also have a name. All right. So that much of preparation work. Next step in your ontology endeavor would then be to formalize what you've drawn on paper or on the whiteboard into RDFS and OWL as we learned it. And as much as preferences, also tools are different. So this is a screenshot of a tool that many of our ontologists like to use and use on a day-to-day basis, which is Protégé. An ontology IDE, if you will, developed by the Stanford University. I think that's a tool that also Henk presented in one of the previous presentations. So obviously that's widely used also outside of eccenca. But as people differ, also preferences differ. So the other fraction in our team of ontologists actually like to be very close to the data. So they, instead of going to an ontology IDE like Protégé, they very much love to work with their code editors of choice. Here's just a screenshot of, I think it's Visual Studio Code, which is here installed with a syntax highlighting scheme for RDF data, which obviously is helpful. And we in eccenca even use a third kind of tool. We developed an Excel template that can automatically be processed into an RDFS and OWL ontology. And that's actually very easy to fill. You just have a handful of sheets where you note your classes, where you note your relations, where you take note of attributes. and data types and or individuals if you have them. And it's easy to comprehend, easy to understand. And that's actually doable for domain experts without too much graph knowledge. And that's also why we like this kind of tool. And obviously, this was just a very brief high-level overview in the topic of ontology development. So if you want to become or need to become an ontologist, there are extensive resources on the web, two of which we actually working with are linked here. So there's a good book by Dean Elmelang and Jim Handler, Working Ontologist, and there is a good free web resource by Leigh Dodd and Ian Davis. It's here linked to the web archives because the obviously original resource has already gone, but it's still available, and I think it's worthwhile to tap into that one. All right, just a couple of more things. As you learned that tools might be different, and also the preferences of the ontology developers might be different. And with these different paradigms, so to speak, and also tools, the quality of the result of their work might be varying. And to harmonize that, we actually developed some guidelines and some governance structures to actually deal with ontologies, to develop ontologies, and to guarantee a certain level of quality. And it actually starts with treating ontologies and the ontology artifacts like code. So we Git revision them. It's also something that the One Record team is doing. So they publish and develop the One Record ontology on Git. But what we also are doing is we put a continuous integration and continuous development pipeline on top of those ontology repositories. So we automatically apply integration and test procedures. So with integration, we mean we do syntax checks, we do consistency checks. With tests, we mean we check for modeling pitfalls and for actual code quality problems. And we also report these problems as bugs, like bugs in software. So we pass those commits back to the authors of those commits in order to have them fixed. And what we also do in terms of this CI/CD pipeline, we automatically generate visualizations and documentation artifacts that very much foster the discussions with the domain experts that are probably not graph experts in order to take the ontology to the next level, to the next iteration. Here just some impressions. So this is actually our ontology pipeline. So we use an integration server called Bamboo. You actually see some commits, and you also see the number of tests that we are running on top of the ontology files. And in this case, you see 2 of the tests, for instance, failed. And okay, by the way, it was me that caused it. So that's actually helpful because you can pass this commit back to the author and ask him to actually fix those problems and then resubmit his work. This is just an impression of our ontology visualization tool. So there are many tools out there that help you to visualize ontologies. Some are, for instance, also available in Protégé. Our own software provides a visualization built in, but for the specific CI/CD pipeline that we were doing, we developed even our own tool, which is called Altodot. The result of this visualization is shown here. And also as part of this pipeline, I announced that already we do generate documentation artifacts. This is done through Widoco. Also something I think Andra will provide some more details about it in a couple of moments. All right, that much about building ontologies. So the next part is how do you actually take them live, right? How do you operationalize? How do you utilize ontologies? And just some ideas and informations about that. So you already have learned in the last 2 webinars that there is a very interesting core ontology developed by the IATA, the one record where this webinar series is about. So this is very interesting material. So there is an ontology that you all are asked to adopt. There is other work. So for instance, eccenca, we teamed with Epics to work on a very similar approach for the supply chain industry. So we turned the Epics score model, the supply chain operations reference model, into a vocabulary to foster visibility and transparency in the data in the supply chain and along the supply chain. So yet another ontology. So we now know there is a new universal semantic data collaboration paradigm out there. So we accepted that fact. That's interesting to adopt, and it's interesting to exchange data based on ontology and based on RDF with others. That's good. So next step for you is the next step is actually you need to turn your organizational instance data that's typically in data warehouses, databases, tables, XML files, JSON files, you name it, you kind of need to bridge the gap between those source materials and the target ontologies that we just agreed upon. So the question is how you get there. And yet again, I think Andra will allude about that in a couple of minutes. But rest assured, so it's not a question of how, but actually just a question when to start. Because you have tons of materials out there that actually help you to bridge that gap. Just to name a few, for all, let's at least say, non-esoteric programming languages, there are low-level RDF libraries available and out there that you can use to start programming to kind of bridge the chasm, right? There are mapping frameworks. So if you are not the biggest fan of doing low-level programming, there are mapping frameworks and mapping languages available that help you to bridge the gap just by declaratively defining how your data should be translated between its original structure and the domain ontology. There are triple store available from different vendors, reaching from open source to commercial products that are actually out there to host your RDF, your graph data, once you created it. And there are also other animals like whole enterprise knowledge graph platforms. This is something that eccenca is actually doing that can actually help you to bridge that gap. So in a nutshell, our software, we call it corporate memory, is an enterprise knowledge graph platform. And that platform actually comes loaded with everything that you need to mediate between your original structures and graph structures on the other side. So it's basically a jukebox that you can use to play ontologies, to operationalize ontologies, if you will. And that's actually my last slide before I hand over to Andra, just to give you an idea of what tools like eccenca corporate memory are doing. This is basically a very brief overview of our user journey and the functional areas that we provide. So typically, we start our projects of creating graphs, obviously with raw data, so with data files, with databases, with APIs, and with ontologies or vocabularies, as we also often call them synonymously. And we start into a first phase that we call build. And in this build phase, we have visual tools that not ask you to program something, but tools like our mapping editor or linking editor that even allow you to very quickly bootstrap the mappings that turn your original data into the graph structure that's defined by the target ontology, like the one record scheme or like this scoreboard that I introduced. And with the knowledge graph in place, we have visual capabilities to explore the graph. So we have a graph front end that can be used to examine the results of the mapping process, to refine the mapping process, but also it can be used to deliver actual data directly from the graph to end users by using a declarative user interface language that allows you to shape how the data should be delivered to others. And we also do have the ability to connect to arbitrary consumers. This consume box basically summarizes different API solutions that we have in place in order to directly interact with the graph. Like, for instance, you would want to write SparkQL queries. But we also do have the ability to kind of retabulate the graph data and expose it as a SQL endpoint. We do have integrations in different applications. So for instance, we have the ability to use Jupyter notebooks to interact with the graph. We have connector components for Power BI. We have connector components for Redash and other solutions, right? Just to give you an idea. All right, so we are now at the part number 4, where I hand back over to Andra. And we'll be back after that with Andra for your questions.
Hello, everyone. Thank you, Rene, for this great presentation. Now, after seeing this overview on how we are actually creating ontologies, I'm going to present to you how we are going to do this the one record way. So I'm actually a developer for IATA, and I'm going to get you through the steps that we have followed in creating our one record ontology. So first of all, let's go through the one record data model components. When we have started developing the one record ontology, we have first stopped on some questions. in order to determine the domain and the scope of this ontology. For example, the first question was, what is the domain that this ontology will cover? For us, it was quite obvious because we are working in the air cargo industry, so our ontology should cover the whole freight supply chain. Then what was the purpose for which we are going to use this ontology? For us, it was one of the main reasons was to replace the legacy system and the processes based on mostly paper to a complete digitalized view of the shipment. Then we were also thinking about what kind of information this ontology should cover. So on this question, this was also quite easy because we are aiming at covering the whole freight supply chain processes. And then if we were thinking about, okay, then we have the information, we know the domain, but who is going to actually create it, who is going to actually use it, and how are we going to maintain such an ontology? For that, we have created a group of experts on the data model, and they are from the whole, there are all kinds of stakeholders from the supply chain and from the air cargo industry. And together they have brainstormed, they have looked at the current legacy systems, they have looked at the current processes, and they have built together a data model from which we have defined the ontology. And for the use, this is aimed for the whole, all the partners, such as like shippers, forwarders, airlines, IT providers, customs, ground handlers, etc. There are many, many of them. For the maintaining, this is also maintained by the team of the data model experts, but also as it is published on GitHub, and it's open source and free for everyone. Everyone can contribute at enriching and also at maintaining the ontology. And how can we share then this ontology? As I said, the ontology can be found on GitHub. So everyone can access it and download it and also make comments on it. Regarding the components of the One Record data model, my colleagues Christophe and David have made very nice presentations last week regarding these components. You can, if you have missed it, you can find it on our One Record page on the IATA website. I'm not going to go through all of these components in detail, but just as a small overview, we have one of the first component is design principle, which is a document that can also can be found on GitHub. It contains the definition of the main terms used in the One Record. For example, piece, transport segment, and all these kind of technical words. Then we have also defined the pillars of the One Record standard. So I encourage you to go and take a look at this document. Then we have a conceptual data model, which is a high-level representation in a diagram of the main terms of the One Record standard. Then there's a logical data model, which is kind of the conceptual data model, but in more detailed way. It's both represented in a UML and then in an Excel file, and it defines all the objects and their properties and then the relationships between them. Also, we have defined a few use cases. The use cases were meant to make sure that the logical data model, the conceptual data model, and the pillars, the design principles were in a way valid, and they covered all the needed scenarios. So every time, for example, we enrich the model, we add new objects, we go through the use cases and make sure that kind of we don't break them, that they are still working correctly. And then we have the fifth component, which is the ontology that we define at the end of this kind of this process. So today I'm going to go deeper into how we actually came up with this ontology and how do we create it. As I've already said, you can see the link there. You can find everything on our GitHub page. So yeah, talking about that, this is a screenshot of our GitHub repository. Please go there and check the files. And if you have any questions, you can come back to us anytime. Okay, so let's go through the ontology creation one record way. First, we have used also a Protégé tool. Of course, we have tested many available tools on the market, but we chose this one because it was free and open source and quite easy to use for beginners because, well, we were beginners when we started. So it was quite straightforward and it has a very nice user interface and kind of easy to figure out. This tool is developed by the Stanford Center for Biomedical Informatics Research and is one of the oldest and most widely deployed ontology modeling tools. It enables the creation of classes, the hierarchy of classes, properties, extra information about properties. It has also nice visualization tools. And yeah, for us, it was perfect. Then we have split the creation of the ontology in 4 main steps. Of course, there are other smaller steps in between, but at the high level, then it's a very iterative process. We start with like definition of the models and terms that we are going to use for the ontology. Then we created the classes and their hierarchy. Then we have gone through their properties and see the types of the properties and their and added some extra information about those. I'm going to show you a bit later. And then from all that, we have generated what we call a turtle representation. Actually, it's a file in a way that contains the whole vocabulary. It's generated automatically from the Protégé tool, and it can be used by applications, by developers to kind of create applications that are one record compliant and transform the physical freight information into machine readable data. Okay, so as I was saying, the first step is the definition of the models and terms. Again, last week we have gone through this diagram. My colleagues explained very well what all these terms mean and how we managed to get from the to create them as digital twins of real cargo models. I'm not going to go through details of them, but this is what we call the conceptual data model. So at least here, when we have designed this diagram, it was already clear for us which were the terms that we are going to use in our ontology. Okay, so from those we have created the classes. Like in our one record ontology, each one of that blue box, it's a class. So we have just created those under Protégé and also defined the hierarchy between them. After that, well, the classes by themselves, they don't tell too much, so we had to define their properties. For example, let's say that a shipment has a creation date or a consignee. Those kinds of information, they are defined under properties. There are 2 types of properties. Rene kind of explained them very well a bit earlier in his presentation. So there are data type properties and object properties. For example, the data type properties are things like dates, strings, integers, and all sorts of primitive data. And the object properties are properties that kind of are linked to another object. For example, let's say that in a shipment, you can have a creation date. The creation date is a data type property because it's simply a date. And then you can have a consignee, which is an object property because a consignee, it's already an object by itself. It has a name, an address, and all like phone number and all sorts of extra information. So it's by itself an object. We have also added some extra information to these properties. For now, the one record ontology contains cardinality, a domain, and range. These are the only things that we have defined by now, but they are quite sufficient as restrictions for what we have defined. The cardinality is just to say if a property is mandatory or not, and if it's a single object or an array, for example. Then the domain, you should know to which domain a property takes part of, and the range is also to know what is the value that this property can take. So this is kind of the high-level presentation of the properties. And then after we have created the classes and the properties and added the cardinalities and all the restrictions under Protégé, then Protégé has this very nice feature that you can just generate a representation in several formats. We have used Turtle because we have found it that it's a bit easier, it's a bit more readable. And there are many tools that can kind of read it and generate and can be used by different types of applications and libraries. I'm going to show you also a bit later. This Turtle file, as I said, it's on our GitHub repository, and from that, it kind of takes the advantage of being under version control. So each time that there's a modification, you can kind of compare the version before with the version after, which is really good for like kind of traceability of the content. Okay. So after we have seen there's the one point that I also didn't mention, but we are also creating instances of these classes, but we don't have a real process for that for now. We are mostly using it in our API testing when we directly generate JSON LD objects. So this is why I didn't go through that now. But you can find more information about that. I'm going to tell you when and later. From the ontology tools point of view. So after we have created the Turtle visualization representation of the ontology, we are using that Turtle file together with a tool called Widoco. Actually, it was Rene that has introduced me to this tool, and it was a very nice suggestion from his side. And then on our side, we needed just a few days to kind of make it production ready. Like it was a bit like a wizard tool, let's say. So actually what Widoco enables is a very nice W3C way of visualizing the classes and properties from an ontology. And also it comes up with a visualization tool, which is very graphical, and it makes it quite nice, like because an ontology can be quite heavy, so having a tool to see exactly how the objects are interlinked, it's pretty useful. And then it also has some very nice tool that is called OOPS, and it's actually an ontology evaluation. As we don't have, because you have seen that, for example, Rene at eccenca, they have this continuous integration tool on Bamboo, where they can create their own script to verify that the ontology is correct before pushing it to GitHub. We don't have that yet on IATA side, but already by using this kind of OOPS tool, you can already see if there is something wrong with our ontology before making a pull request and committing it to the GitHub. So yeah, as you can see, that's a screenshot from the first side. That for the first time that I have evaluated our ontology with OOPS, and we had some quite a few errors there. They were not critical, but of course there were some of them that were important, and then we made sure that we have fixed them since then. Now I want to do something really crazy and share my Chrome for you to see actually live. It might break in between, so I'm going to apologize before that. Let me see how I do that. So hopefully now you see my screen. Yes, great, success. Okay, so this is our Widoco visualization of the one record ontology. As I said, it contains all the classes, all the object properties, the data properties. Well, it's a bit maybe difficult to read because we have a lot of objects and properties, and it's not very easy to go through them all. But what I wanted to show you is this nice visualization with the web wall. I'm going to share you the link afterwards so you can play with it after the webinar if you wish. You can also filter, like, for example, the degree of collapsing and have like more detail visualization of it. You can, of course, zoom in, zoom out. I'm not going to go through that because I don't think that you are going to see a lot of things on your screen now, but you can play with it afterwards if you feel like. We have kind of the whole description of the classes with their details and their the properties and etc. I'm not going to go through that, but this is a very nice tool for visualizing an ontology because not everyone can read Turtle, not everyone has Protégé on their machine, so at least this kind of allows of having a first idea of what this is about. Also, I'm going to show you this eval, if it works. It's well, for some reason it doesn't charge, but maybe the internet is quite bad. Or maybe it's demo effect. Well, it's a little bit slow. Success. No, it worked. So now you can see actually the evaluation of our ontology. Again, you can go through all the warnings and then try to figure out what they are and then fix them. Okay, so now I'm going to go back to my part of the presentation. See how that works. Okay, so our next tool that is used by the one record team is something called JOPA or JOPA. I don't know exactly how do we pronounce it. Let's say JOPA. It's something called object triple mapping. For those who are working with object-oriented programming, I'm sure that they know already there are tools like what we call ORM, like Hibernate and MyBatis, and I think that there are many of those that kind of map database models data to object-oriented models, for example, Java POJOs. There's something like that for your DS, which is pretty great because, as you can imagine, we have let's say 30 classes with a lot of properties. If we manually create the Java objects from those and we have to maintain them, and every time there's a change, we need to manually change something, it's a lot of work and it's a lot of maintenance, and it's very prone to errors. So this kind of tool is really useful because it kind of magically generates Java objects from the Turtle file. We have an implementation of the usage of JOPA on our Java repository. You have the link there, so if you want to take a look, please do that. But it's very, very nice because, it kind of saves a lot of time to the developers, and they don't need to manually kind of read the ontology and then figure out what are the properties and how those work. Okay, so that was a high-level presentation on how did we create the one record ontology and which were the tools that we have used for that. As also Rene has said earlier, I'm insisting on that there's no correct single way to create an ontology and to implement it. So you can find many tutorials and documentation online on how to create those. But this was our way, and we think that until now it works pretty fine, but we are constantly learning and improving it. So stay tuned, because we are going to come with more details afterwards. Okay, so as a bonus, for those who want to deep dive more into the one record standard, we have created, I think now we have like 10 one record insights that are small articles written by the one record IATA team on different topics around one record. Some of them are technical, some of them are project related, pilot related. If you are interested, please go there and take a look. They are short, so they shouldn't take a lot of your time, and I think they're very good for making understand some of the topics that I have discussed already before. Then we have our first one record white paper from a series of 3 white papers. This first white paper matches pretty well our webinar from today. It kind of touches the semantic web principles, what's linked data, what's JSON-LD, how do we create an ontology, what's the object triple mapping, how do you use everything in one record. So I, again, encourage you to go there and take a look. And also, don't miss our future events. We have 3 more webinars left from our series, every Tuesday until the end of July. Then we are planning an online hackathon, the beginning, actually mid-September, and then the Digital Cargo Conference also in September. So please check our website and subscribe. So now we get to the part 5 with the Q&A. I can see that we already have a lot of questions. I propose that maybe we can choose one by one. Maybe Rene, if you want to start, because I've talked already a lot, so maybe people want to hear you. Let's speak a question and then answer it, I guess.
That's fine. So am I on air again? Yeah, I see the live here. Oh, fine. Okay, I'll just start top down probably with a question. What is the difference between a relational database and an ontology? And probably we can even combine it with the next one. What are the advantages of an ontology compared to, for instance, a traditional relational database model? All right, I think we can take both here. So from my point of view, what's the major difference is the agility of how you can deal and work with data, right? So if I look at a specific data model in a database, and specifically also when that database is a live database, constantly populated with data, where applications are attached and so on and so forth. Database administrator, in my point of view, are a bit hesitant to adopt changes quickly in those structures, right? So you have the tables, so you have a very careful test process, and there is no easy way to, with a very low impact, introduce new changes to it. That's number one. So agility and speed of how to deliver new application and changes, in my point of view. And secondly, also when I look at how documentation for relational databases are delivered, there is I would say, media break between how you can make use of it, right? So if you look at documentations of databases, they are typically in PDF documents and Excel files or whatsoever, but not directly attached to the SQL files that basically contain the dump of the structure of the database, right? And also there is no consistent way of adding business information, semantic meaning to the individual columns of those structures. / I would say there's also no good habit and no good practice in terms of database developers to actually comprise those things into the data models of a relational database, right? So rather I see the habits of using abbreviations and acronyms as column headers and leaving it then to the users of the database to decipher what those acronyms are actually meaning, right? And so this is what I mean with decoupling on media breaks between documentation and meaning of data, whereas the ontology way is actually very much data-centric and data-focused. So the ontology typically has, and that's even probably true in multiple languages, you typically have a very clear definition of what the data is as I said, probably in English, in German, in French, in Spanish, in, I don't know, Mandarin, whatever you need. So you can have it documented in multiple different languages. You can have that documentation packaged along with the data dumps that you can pull from a triple store. So it's very much basically one package and not too many media breaks in between. And also the visualization we looked at, this was not from a separate tool where you start to draw the conceptual level of the ontology again. That was directly generated from the live ontology, and I know you can do similar things from an ER model. That's true, but with the lack of all the semantics in the ER model, you simply have a set of tables connecting to other tables, and not so much about what it really means that those two tables are connected, right? And specifically think of cross tables for representing n-ary relations. It's pretty difficult to really describe what the actual semantically true relationship is between those three tables that you connect, right? And that's basically just different, and I would say from a human perspective, more easy to comprehend and understand in ontologies compared to databases. All right, maybe Andra, if you want to take the next one.
Okay, so I'll take the next one. Ontology seems very conceptual. How do I make the move from an ontology to actual code? Which is a really good question. I think it covers a bit the object triple mapping discussion that we had a bit earlier. It's true that, for example, when I have first seen like a turtle file, I was like, okay, what am I going to do with that? How am I going to make an application that, like, how can I make an API that reads that file? There are not so many tools that are available for transforming a turtle file into Java code or Python code or some other languages. There are some object triple mapping libraries, for example, like JOPA or I think that like Olga, I think that Gina from Apache, they can also map RDF stores and ontologies to actual code. But yeah, I think that a lot of our pilots, they are doing it manually, which is a lot of work and a lot of maintenance. Or we can already use existing libraries. But yeah, there's no like correct way for doing that. It depends on the programming language that you are using, on what sort of application that you are going to implement. So yeah, and on the size of the ontology, because if it's a small ontology, maybe you can create your own models locally and do your own code that reads it. But if it's like a really huge one, maybe you should just go and try to find some existing library that can automatically generate, map it to your databases or RDF stores. That's it from my side. I think that you can go next, Rene, if you want.
Yeah, I take the next one. Or probably, if you allow, I could also quickly add to that, because in my experience, one of the beauty of using ontologies is actually that many of the different layers that you have from conceptual to technical to physical are actually taken out of the equation when you truly adopt an ontology-based paradigm here. Because the only step that you need to take is actually the step from the whiteboard to the formalism, right? You need to take the boxes and the connections that you draw on the wall. You need to take them into RDF, and then you already have everything that you need, but it takes to go to the code. Right, because the data that you will actually create will pick up the IRIs, will pick up the concepts that are comprised in the ontology. So there is no technical translation into a technical layer, at least not in the triple store database. If for some reason in your application you will not want to write SparkQL or JSON-LD queries directly, so potentially the object triple mapping is a way to go forward, right? That would be an interesting layer that you would then want to have in advance. But that's the same thing that you have with relational tables as well. So if you want to do an object whatever mapping, then there is this abstraction layer in between. All right, maybe that's so much to be added here. How different ontologies can be compatible? That's an interesting one. Andra, I'm not sure if you in the background can open up your Widoco documentation again. Because in the very top of this page, you see a nice box with all the different ontology references that you are typically using. Sorry for that. Yeah, perfect. Exactly that one. right? So here you see many IRIs that point to one record IATA. That's fine because that's actually what they use and define. But exactly what you just highlighted, so terms, or below you see XSD or RDFS. So you see actually references to foreign ontologies, so to speak. And what makes them compatible is basically that all they are based on RDF. So whatever it takes to adopt another ontology is simply that you agree that you're using the same kind of data grammar. Everything is a triple. And what you typically do in order to mix those ontologies is you borrow concepts from those other ontologies. Like, for instance, from RDF, you will most always borrow the relationship to declare a type, right? So when you make the statement that something is of a specific type, you would want to use the RDF property type for that, right? So you also most often would want to use the XSD defined data types. You would want to use subclass of relationships from RDFS. You would want to use things like I don't know, title or terms from DCT and so on and so forth. So that's actually what makes those things compatible. You simply can agree and remix concepts from those ontologies by simply using them in your documents, by simply basically picking up the IRIs that have been used by declaring those concepts. So probably I'm speaking a bit Greek tongue, but if you take a look into those elements, I think you will understand very quickly what I'm referring to. So hopefully that answers that. I think that fits quite well because the next one goes about one record. So Andra, I think your turn.
Yes, 1 second. Okay, so the next question is, how do you actually use ontologies on one record servers or pilots? Well, there's no correct way of using the ontology on a pilot, for example. Every pilot, they have their own way because they're using different types of databases. Some of them they're using relational databases, some of them NoSQL databases. Some of them they're using object-oriented programming, some of them they are not using object-oriented programming. So everyone has their own way of building their own servers. So it depends. I guess they're like on our sandbox, as I said, we are using JOPA. I know that some of them are using Gina, some of them they are creating their own models from scratch. There's no correct way. I guess that everyone can kind of can be creative and they come up with their own solution on that. And that's the beauty of it, like you're not forced to use one way. You just can create your own code. And I think that I'm going to take also the next question as it's a bit related to the air cargo, if you allow me, I think. Is there any other ontology available for air cargo? That's a good question. Honestly, while I was browsing online, like when I have started to work at ETA, like a year ago, I have started browsing online about like ontologies and airlines, and I have found some academic like rated ontologies that were kind of related to airlines or cargo, but I'm not sure if those are used anywhere or they are just like maybe test ontologies for some sort of projects at universities. I think that ontologies are quite new in a way in the air cargo. I'm not sure that those exist yet, but of course, if somebody implements an air cargo ontology, we would love that. In a way, we can integrate with them because this is the beauty of ontology. Everyone can create their own, and then we can integrate and make them work together. So yeah, I can do some more research and find if there's something out there, but not for my knowledge. Okay.
All right, let me probably take the next one, also the next two. Let me share my screen quickly because that could be helpful for answering this. Let me share that one. So first of all, what is required in order to pick up a property as we defined it in the database? I'll try to answer that from two perspectives. So the first perspective would be the RDF perspective, as I would say it. Let me just scroll to that model. So for instance, when we take a look at the graph I was introducing and we want to put this graph into a triple store, into a graph database, If we have a formalization of that graph available in RDF, right, that defines this Jimmy Page resource that says this resource is of a type of person, and all those yellow things have been basically defined in our ontology about music, then my triple store is directly capable of preserving all those three elements for each statement. So literally put a triple store stores triples, right? A triple store stores these kind of subject predicate object relations. So all the defined classes, all the defined predicates can be directly consumed by a triple store. If the question was more directed to how this relates to my relational database and how this would be translated into a table in my relational database, that basically was briefly discussed in this picture here. So the process of doing these kind of relations is called mapping, right? So in mapping, you describe how a table of a database should be translated into a property defined by our ontology, right? So this is literally put, this is what a mapping contains, right? A mapping contains the declaration of how an individual column, probably called name, should be translated in terms of the ontology. So for instance, it could mean that you simply translate the column name into a property called RDFS label, for instance, and then ultimately the RDFS label property in your RDF data would then contain the value of a record of that table, right? Okay, I think that was one answer of this, and I think the other answer, let me just briefly go back to that thing, the relation. Yeah, I think that was of Christoph, and then there was another one. How do I integrate the ontology with my existing database and backend system, right? Also there, I think we just briefly discussed a couple of options here. So one option is using systems like the one I'm picturing here, but if we just go back and discuss about the options that we see here. So there are low-level RDF libraries that we have in place, right? So you simply can start programming to create your RDF code by, for instance, for Java, there is Jenna, there's RDF4J. So these are just two libraries that help you to create RDF data from your Java application. There are mapping frameworks out there that exactly do that step that I was just describing about, right? To describe the mappings and how these things relate. Right, so this is hopefully an answer to that question. How do I integrate the ontology with my existing database and backend system? So with a process like mapping and these sort of things. So Andra, I pass back to you.
Okay, thank you. So I'll pick a next question. Can you explain what, in the one record context, the ontology provides in addition to the logical data model? I assume your classes correspond very closely to the entities in your data model. Trying to understand where the two overlap versus what ontology provides in addition for a data-centric application. One record is. Thanks. Actually, the ontology is kind of the representation of the logical data model. We don't add anything extra in the ontology. It's just a way to make the logical data model machine readable, because you cannot make an API with a UML diagram. You need to kind of translate those terms into a vocabulary that can be read by the machines. So actually, the ontology does not provide anything in addition. It's really respects the logical data model, the classes, the properties. So yeah, I guess that there's nothing extra from that point of view. It's just another type of representation. Okay, I guess that Rene, you can pick the next one if you wish.
Yes, I do. So let me see. I think we close this. What's the difference between a data model and an ontology? I think we kind of answered that already, but let me try it one more time and probably a bit differently. To some extent, they are synonym, right? So also an ontology describes what kind of data do exist in a specific domain, right? To some extent, an ontology so acts like a data model or can walk in the shoes of a data model. But as we tried to outline earlier, an ontology also tries to be a bit more. It tries to not only represent the data, but also tries to represent, capture, simplifies, and synthesize the domain in which the data is typically used. Right. So to that extent, it's not only a technical description, it also can become a technical description, right? So when like you, Andra, did start to top up your domain representation with cardinality constraints, with property constraints, and with all the expressivity that OWL allows, your formalization, your conceptualization of a domain can actually become a very concise and comprehensive data model. But it can be more than that, right? That's what I would reply to this.
Yeah, just to add to that, yes, it can, like for us, as we are kind of beginners in a way in the semantic web topic, so we didn't want to create something really complicated and very difficult to digest. We just wanted to start simple, and I think that for now, like the constraints that we have added to the ontology are sufficient for starting implementing your one record API compatible. So yeah, of course, there are infinite possibilities of constraints and things to be added. But yeah, as it is an iterative process, for us this was the first let's say the first iteration of it. Okay, so I'm just going to take a new question. If we implement the one record ontology, what can we do with that? Well, you can create the one record compliant API that reads and kind of reads and writes one record compatible models, and you can take part of what we call the Internet of Logistics, which is a network of securized one record APIs. And then you can, of course, there are also infinite possibilities on that. You can implement a tracking system. There are many sorts of apps and things that can be implemented with that. You can add one record layer on top of the existing legacy system to make it compatible with other partners from the industry that support one record. So yeah, it's mostly kind of take part of what we call the Internet of Logistics and get to the digital step, like to the next step in the era of logistics, let's say. Okay.
All right, I can take the next one if you allow. It was about, can you search ontologies with Google? If so, will I get a schema or will I get data? Yeah, indeed you can. Right, so you can Google for ontologies, you can Google for vocabularies added with terms that describe your specific domains. So for instance, air cargo ontology, logistics ontology, manufacturing ontology, and so on and so forth. For very specific domains, most likely you will either have a miss than a hit, right? For very generic fields like social media, people's addresses, locations, places, points of interest in general, there will most likely be sufficient and sound ontologies out there. In terms of schema or data, again, you will be able to find both, right? So schema, I think a good entry point for finding schemas or ontologies as such would be this LOV data site, right? This Google for ontologies, as I was referring to earlier. With many of those ontologies, you will also have the ability to find actual instance data. But there are also other pages like the LOD cloud picture that I was showing and the website of those people. They are also linking to actual data sets that not only containing the schema, the ontology, but actual instances of data. You probably noticed, I'm not sure if I'm still sharing, let me try to go back in sharing mode. So let me go back to this cloud quickly. So you probably noticed, I think you can be seen quite well, you probably noticed that there is a big one in the middle that strongly interconnects with many other data sets. It's called DBpedia. DBpedia, for instance, is a data set that has an RDF representation of Wikipedia content. So almost everything that is documented and described in Wikipedia has a IRI and so a link, so to speak, right, a web address and facts about itself contained in DBpedia. So whenever there's a famous person, a city, a place, I don't know, a company that should be able to be looked up in DBpedia, and by that you have actually a hook to base your own statements on top of, right? So if you want to add statements about air cargo, so you probably want to pick up the article and the web address that DBpedia contains about air cargo, right? That's also the reason why you see strong connects to and from DBpedia. Okay. I think that much about this one.
Okay, let's take another question. So, JOPA is a mapping library to generate Java objects from ontology. Is there a similar library to generate C# objects from ontology turtle file? Thanks. That's a very good question. I know that there are from Python. I think that JOPA supports Python, but I'm not sure that it supports C#. I have not personally done any research on C#, but I can do that actually. And let's see if I can share it on our, because we are planning to do a Q&A wrap up after we finish the webinars. So I'm going to try to find the answer to this question until then. But it's a good question. And I guess that I'm also going to take the last one because yeah, we have just 2 more minutes left. Related to the concept of the ontology itself, you said that there is no single way to build it. IATA has already a fair and solid version for the one record project. What is then the end state objective? Is it to have a unique ontology for the air freight industry, or each stakeholders, by contributing to the model, adding their specificities, will then host their own version of the ontology? How will this work? Compatibility, governance. Of course, we are going to integrate ontologies from other industries also, like maritime and the plant. As you have seen on there's a big schema, like diagram with all the vocabularies that we want to integrate together with one record. All those ontologies will kind of be compatible together. But then regarding the versions, when we are defining new versions of the ontology, we are keeping in mind to make it backwards compatible. So if you are using a version from, let's say, 2020, and then in 2021 we are adding new models to that, we are willing to make sure that those 2 versions are compatible. But then integrating existing air freight, other ontologies, as I said, ontologies can, as Rene also said, ontologies can work together easily. So I don't see any problem in integrating other sorts of ontology from other stakeholders. If your API wants to do that, it's very easy to just use as many ontology as it wants. But yeah, regarding the different versions of the one record ontology, we are going to make it short to make it one record compatible. So every time you are, if you're using an old version and your partner is using a newer version, then you can both communicate without breaking the communication, let's say. Okay, so I guess that it's time. We still have a few questions left, but we are going to answer those maybe in the in our Q&A wrap-up. Thank you, Rene, for your time and for the great presentation. You are going to find the recording of this webinar on our IATA page. Then thank you for your time again, and talk to you next week on a webinar relating to the API features of one record standard. So see you then, and have a great day.
My pleasure. Thanks for having me.